Welcome back, students. Today we would be learning how to find the area of this region. Now you're given a square and you have got circles passing through the vertices of the square. And just for the sake of visualization purpose, I wish to show you what exactly this figure means. So you are given a square and you have circles passing through the vertices of the square, something like this and something like this, something like this, and something like this. Okay, it goes like this. I hope you are able to get a picture. So these are all circles. Okay, and the side of the square is r, and so the radius of the circles are also r units. So now we are expected to find the area of this shaded portion. In fact, you can find the area of each of these portions by the following way that I'm going to be illustrating here. So having said that, foremost, since the side of the square is r units, we know that the area of the square should be equal to r squared. Now, if I were to name these portions as alpha, 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 and these portions as beta, 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 and this portion as, say, some t. Clearly, we know that 4 times alpha plus 4 times beta plus 1 time t will be equal to r squared. So let us call this as equation 1. Okay, next, consider this circle. See, actually this is a circle that's moving up like this. This is a quarter of a circle. So the area of this quarter of the circle would be pi r squared divided by 4, right? But just check, when you see that you have 3 beta and 2 alpha and a t making up this area. So you can write that down. So it's going to be 2 alpha, alpha here, and 3 beta plus 1 t in the center that make up this area of the quarter circle, and let us call it as 2. Next, what I'm going to be doing is that I would be connecting this vertex to this point. So let me try to do that. And similarly, I will be connecting this vertex to this point. Side of the square is r units. The sides that I've just connected should also be r units. So I write that down. Now, since all of these 3 sides are r, the angle should be 60 degrees. So we are talking about an equilateral triangle. Now clearly, if you were to see this part along with the circle there, the edges r and the other edge r connecting to the circle, we see that it is a sector. Now we know the area of a sector is given by the formula theta times pi r squared over 360. So this is equal to, the central angle is 60 degrees, the total angle is 360, and you got pi r squared. So simplifying this, we would have pi r squared divided by 6. So this is the area of the sector. Now I'm more interested in obtaining this area, this small segment that you see there. So that could be got by subtracting from the area of the sector the area of the equilateral triangle. Now we know the area of the equilateral triangle. Let me use a space. The area of the triangle should be equal to half times the length of two legs, that's r into r, times sine of 60 degrees, because that's the angle there. So this should be equal to r squared over 2. Sine 60 is root 3 over 2. That is going to be root 3 times r squared divided by 4. So this is the area of the triangle. So area of the sector, it's pi r squared over 6 minus area of the triangle, which is root of 3 over 4 times r squared. So clearly you see that we have got the area of the shaded region. Now you can clearly see that there is also a shaded region here. So this shaded region's area will be same as this shaded region area. So in other words, this shaded region area which you see here will also be the same value that we have just obtained. Now coming back to the part that we wanted, what I'm going to do is I'm going to be taking the entire area of the sector together with this shaded region. So I would be considering this entire part, okay, for obtaining the solution. So to take that, so that area should be area of the shaded part, which we have got as pi r squared over 6 negative root of 3 over 4 times r squared, added together with the area of the sector, that's going to be pi r squared over 6. So if we are going to be simplifying it, we would get pi r squared over 3 negative root of 3 over 4 times r squared. So we have got that on the left side. It's nothing but find out the number of betas and the alphas that add up. So clearly you have an alpha and two betas and a t. So it's going to be 2 times beta with 1 alpha and 1 t adding up to give us this required area. So what I'm going to do is I'm going to be writing down, so the equation obtained are as follows. So the first equation which we have got is 4 times alpha plus 4 times beta plus t is equal to r squared. The second equation which we got was that 2 times alpha plus 3 beta plus t is equal to pi r squared over 4. And then the final one is alpha plus 2 beta plus t is equal to pi r squared over 3 negative root of 3 over 4 times r squared. So we would be using these three equations to obtain the value for alpha, value for beta, and value for t. So now we would be using equation 1 and 2 and solving them for t. So we would be solving for t. So that would give us, changing the sign, negative, 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 and negative. T can be cancelled. 4 alpha negative 2 alpha would give us 2 alpha. 4 beta negative 3 beta would give us positive beta. On the right side, we've got r squared negative pi r squared divided by 4. So let me name this as equation 4. Now, from 3, we know that alpha plus 2 beta plus t is equal to pi r squared over 3 negative root of 3 over 4 times r squared. So have this in mind. So what I'm going to do is I am going to be substituting 4 in 2. Okay, so my 2 is actually 2 times alpha plus 3 beta plus t is equal to pi r squared over 4. This is my 2. Place 2 alpha and beta equal to r squared negative pi r squared over 4. And from here, I would be able to solve for alpha. So I change the sign here, negative, negative. So let me place a 0 there just for continuity. So 2 alpha can be cancelled. 3 beta negative beta would give me 2 beta plus t is equal to pi r squared. I have a negative sign here, pi r squared over 4 negative r squared positive pi r squared over 4. So this could be simplified and rewritten as 2 beta plus t. Pi r squared over 4 can be added with pi r squared over 4. That would give us pi r squared over 2 negative r squared. Now let me name this as 5. So now I already mentioned to you that we have 3 to be as alpha plus 2 beta plus t is equal to pi r squared over 3 negative root of 3 over 4 times r squared. So I would be using 5 in 3, and that would give us, in the place of 2 beta plus t, I would be substituting pi r squared over 2 negative r squared, which is equal to pi r squared over 3 negative root of 3 over 4 times r squared. Now let us simplify and obtain the value for alpha. So we got pi r squared over 3 negative root of 3 over 4 times r squared negative pi r squared over 2 and positive r squared. So we've got all this. Now what I'm going to do is I'm going to be clubbing pi r squared over 3 with pi r squared over 2. So pi r squared over 3 added with pi r squared over 2. And then we have got negative root of 3 over 4 r squared positive r squared. Now foremost I will simplify this. So this is going to be, the LCM is 6, so this would give me 2 pi r squared negative 3 pi r squared. And I can take the r squared out, and that would give me root of 3 over 4. Since I've taken a negative sign out, so this will be negative 1. Right? So this is equal to 2 pi r squared negative 3 pi r squared would give me negative pi r squared over 6. This is going to be negative r squared of root of 3 negative 4 divided by 4. And of course on the left we've got alpha. Now I can take r squared out and rewrite it as, of course we have got a negative sign, so I can place the negative sign out and write this as pi over 6. Since I've taken a negative, this will be positive. So positive of root of 3 negative 4 divided by 4. This is the value of alpha. So taking the negative sign inside, this would be r squared of negative pi over 6, negative root 3 over 4, and positive 4 over 4. So I can rewrite this as r squared of 4 divided by 4 can be written as 1, followed by negative pi over 6, negative root 3 over 4. So this is the value of alpha. So now clearly I will be using this value of alpha to obtain the value for beta. So what I'm going to do is I'm going to be substituting the value of alpha in 4. So using alpha's value in 4 we get, so we got 2 times alpha. The value of alpha is r squared of 1 negative pi over 6 negative root 3 over 4 positive beta is equal to r squared negative pi r squared divided by 4. Now moving this to the right side, I would get beta is equal to r squared negative pi r squared over 4 negative 2 times of r squared of 1 negative pi over 6 negative root 3 over 4. Removing the parenthesis and simplifying, I would have r squared negative pi r squared over 4 negative 2 times r squared positive 2 times r squared pi over 6 positive 2 times root of 3 times r squared divided by 4. On the left it's beta. So we can simplify. I got a pi r squared and pi r squared over 6 with a 2 there. So I can reduce this. 2 can divide 6 3 times. So just clubbing the quantities. So negative pi r squared over 4 positive pi r squared over 3. Let this be one quantity. Now 2r squared and negative 2r squared can be added. So that would give me negative r squared. And I have positive 2 times root of 3 divided by 4 times r squared. So we need further simplification. So taking the LCM as 12, this is going to be negative 3 times pi r squared positive 4 times pi r squared, and taking r squared out, if I were to take a negative r squared out, I would get 1 negative 2 times root of 3 divided by 4. Of course I could have reduced it. Anyway, I will do it in the next step. So this can be rewritten as 4 pi r squared negative 3 pi r squared would give me pi r squared divided by 12, and negative r squared This is going to be 2 there. So you got 2 negative root of 3 divided by 2. I can simplify this by taking r squared out. When I do that, I would get pi over 12. And this would be negative 2 over 2 and positive root 3 over 2. Okay, because I'm taking the negative inside. So that would mean negative 2 over 2 and positive root 3 over 2. So I can further rewrite it as r squared of pi over 12 positive root 3 over 2 negative 1. And on the left, it's going to be beta. So this is the value for beta. Okay, now finally, students, we have to get the value for t. Okay. Now, to get the value of t, what I'm going to do is I will be substituting the value of alpha, beta into equation 3. So let us do that. Substitute for alpha, that's going to be r squared of 1 negative pi over 6 negative root 3 over 4 plus 2 times of beta, which is r squared of pi over 12 positive root 3 over 2 negative 1 positive t is equal to pi r squared over 3 negative root 3 over 4 times r squared. Let us move all these quantities to the right, so keeping only t alone. So t will be equal to pi r squared over 3 negative root 3 over 4 times r squared, and this is going to be negative r squared of 1 negative pi over 6 negative root 3 over 4 negative 2 times r squared of pi over 12 positive root 3 over 2 negative 1. Okay, so now we got to simplify this. So removing the parenthesis, we would now have pi r squared over 3 negative root 3 over 4 times r squared negative r squared positive pi r squared over 6 positive root 3 times r squared over 4 negative 2 times r squared pi over 12 negative 2 times root of 3 times r squared divided by 2, and finally positive 2 times r squared. Now clearly we can do further simplification, and that would be cancelling the 2 here. Now 2 divides 12 6 times, and that's it. So rewriting, we now have pi r squared over 3. I'm looking for pi r squared term, adding together with pi r squared over 6, and then you got one more term. So this is going to be negative pi r squared over 6. And are there any other terms? So I have taken care of this, taken care of this, and taken care of this. So I've got left root of 3 times r squared over 4, a negative r squared, positive root of 3 r squared over 4, and then I've got a negative root of 3 r squared and positive 2 times r squared. So I've written this down, I've written this down, I have written this down, I've written this down, I've written this down, I have written this down, and I have written this down. Okay. Now positive pi r squared over 6, negative pi r squared over 6 can be cancelled. So that would mean we now have pi r squared over 3 with a negative r squared followed by negative root of 3 times r squared positive 2 times r squared. I can add these two things together, and that would give me pi r squared over 3 positive r squared and negative root of 3 r squared. So if I were to take r squared out, I would be having pi over 3 positive 1 negative root 3, and this is my t. Therefore, to sum up values for the question wants us to find the area. So let me put down the areas together. So this is t, and then we've got alpha, which is r squared of 1 negative pi over 6 negative root 3 over 4. And then we've got beta is equal to r squared of pi over 12 positive root 3 over 2 negative 1. So we got the three regions that are required. Now for any given value of r, you would be able to calculate and solve the problem. So this completes the solution for the question.